In this video, I want to discuss what it looks like to graph linear inequalities in two variables, x and y. But before I get to my examples, I want to go back a little bit and kind of make a connection between the inequalities in one variable that we graphed previously. So there's a lot of connections we can make, and I'm going to start here and then move forward. So here in this example, I have x is greater than or equal to 3. So the way we graphed this was we had our real number line and we found 3 and we kind of put a circle here at 3 to mark the starting point. And we had to decide, is this circle going to be a filled-in circle or an open circle? And remember, that indicated whether or not 3 itself was included in the solution set. So x is greater than or equal to 3, and because it was equal to, we went ahead and we filled that circle in. Now the next thing was, are we going to shade to the right or are we going to shade to the left? So x is greater than or equal to 3, so I'm looking for numbers that are larger than 3. So I'm going to shade to the right of 3 because those are the numbers on the number line that are larger. Okay, so this is what this looked like. So two things. One, we went to the right. And 2, I used a solid circle. Okay, so I'm going to come back to that. Okay, in the second example, I have x is less than negative 2. So I find negative 2 and I put my circle here. And then I ask myself, am I going to fill this circle in or is it going to be an open circle? Well, if x is less than negative 2 itself is not included in the solution set. So I'm going to leave it open. Okay? And then x is less than negative 2, so that means I'm going to head to the left because those are where the numbers are less than negative 2. Okay, so I shaded to the left and I left my circle open. Okay, so these two pieces are going to make direct connections when I start graphing linear inequalities in two variables. So remember these two pieces of information, whether I shaded to the right or the left, so greater than or less than, or whether I had a solid circle because my solution set included the endpoint, or whether I left my circle open because the solution set did not include my endpoint. In this first example, we have y is less than or equal to negative 3 halves x plus 1, and it looks like this is in slope-intercept form. And remember, slope-intercept form is y equals mx plus b, where m is your slope, or your rate of change, and your b value is your y-intercept, or when you're graphing it, it's your starting point. Okay, so when you're graphing these linear inequalities in two variables, we'll always talk about 4 important pieces of information that we need. Okay? So the first one is going to be your slope. We always need to know the slope of the line, which is your rate of change. Your second piece of information that you need is the y-intercept, or your starting point for your graph. Okay? Your third piece of information you need is the line going to be solid or dashed? So I'm going to say line, solid or dashed. And then the fourth one is, where are you going to shade? Are you going to shade above or below? Shade above or below. Okay? So here are these 4 pieces that we'll always need, and it's really easy to get them from the inequality when your inequality is already in slope-intercept form like this. Okay? So let's take a look. It looks like our slope is going to be negative 3 halves, because that's right here. Okay, so I'll say my slope is negative 3 halves. My y-intercept is this plus b, so it's going to be a positive 1. Okay, so is my line solid or dashed? So let's go ahead and recall from our first examples, and I'm going to make this connection. If it was equal to, the circle was solid because it included that endpoint, but if it was not equal to, the circle was open because it did not include that endpoint. So the direct connection is, if it's equal to, then this line we're about to draw is included in the solution set. And that line is called the boundary line, and it will be included in the solution set. So that means since this is equal, we're going to have a solid line. Okay, and the fourth piece of information, are we going to shade above or below? Well, this says y is less than or equal to, so the less than means we're going to shade below. Okay, so I have these four pieces of information, so let's go ahead and put everything together and see what this looks like on the graph. So we always start at our y-intercept, positive 1, so our y-axis is the vertical axis, so let's go to positive 1. And then we're going to use the slope, negative 3 over 2, to plot some more points on my graph. So remember, a slope of negative 3 halves means a negative 3 over a positive 2, or a positive 3 over a negative 2. So either one of these will work, and we'll use one of them to make points to the right, and one of them to make points to the left. Okay? So let's see what that looks like. So let's go down 3, and then over to the right 2, down 3 and over to the right 2. We could also go the other way and say up 3 and back to the left 2, but we can only do that once because then we run out of graph. Okay, so I'm going to grab my handy dandy straight edge and I'm going to draw this line, and it's going to be a solid line, so I don't need to worry about making dashes. And when I draw my lines, I'm going to take the line just beyond the boundaries of my graph. So I have this nice division here on my graph, and then of course I'm going to put arrows on each end because that indicates the line goes on forever and ever. Okay, so I have used my slope, I have used my y-intercept, and I know that my line was solid, so the last thing to do is we need to figure out where we're going to shade. So we said that since y was less than or equal to, so the less than, that means we're going to shade below. What does below mean? Well, we have our line right here, and we have, remember, our y-axis is our vertical axis. So below means we're using this y value above or below, and we're going to use this line as this boundary. So below actually means literally just below this line. Okay, so I'm actually shading below the line. Well, what if you're not sure about that, or maybe that's a little confusing? Then the other way you can do it is to use a test point. Okay, so maybe let's use a test point in this region and a test point in this region. So maybe let's try negative 2, 0. Okay, so here's a point right there. So negative 2, 0. And then let's use another one. Let's use 4, 0, because that's right there on the axis too. Okay, so we have negative 2, 0 and 4, 0. We're hoping that negative 2, 0 gives me a true, because I already shaded there, and we hope that 4, 0 gives me a false, because that's over here in the non-shaded region. So what we're going to do is plug it into my inequality, and just see if it's true or see if it's false. So we have y is less than or equal to negative 3 halves x plus 1. So negative 2 is my x value. 0 is my y value, so let's plug it in. So y is 0 is less than or equal to negative 3 halves times negative 2 plus 1. Okay, well here I see that this negative 2 can be written over 1. So my 2's will cancel. My two negatives, I can go swoosh, swoosh. So I have a 3 right here. So 3 plus 1 is 4. So 0 is less than or equal to 4. Well, that works. That's true, which is good because we shaded over there already. Okay, so let's just go ahead and verify that 4, 0 gives me a false. So 4 is my x, 0 is my y. So when I plug this in, 0 is less than or equal to negative 3 halves times 4 plus 1. Okay, we'll put that 4 over 1, and we can cancel some things here. So negative 3 times 2 is negative 6. Plus 1 is negative 5. So 0 is less than or equal to negative 5. Well, no, that is not true. That's false, right? Which is good because we didn't shade over there. So, a couple of ways you can figure out where you need to shade. You can look directly at the symbol for your inequality and then just use your y-axis and go from there. So y was less than, so we shaded below the line. Or you can use test points, and you can figure out what makes it true and what makes it false, and you'll want to shade in the true region. So here's our first example. Y is less than or equal to negative 3 halves x plus 1, and that's what the graph will look like. The second example I want to take a look at is 4x minus y is less than 3. So there's a couple of things different here about this example than the first example. So we're written in a standard form instead of slope-intercept form. So if we want to grab our slope and y-intercept, we'll have to kind of rearrange this. This is actually less than instead of less than or equal to, so that'll be different. So let's go ahead and rearrange our terms and write this in slope-intercept form. So we'll subtract 4x from both sides, and we'll have negative y is less than negative 4x plus 3. Of course, we want the y to be by itself, not a negative y, so we'll divide every term by a negative 1 to get rid of that negative. But remember, when you multiply or divide an inequality by a negative, you have to flip the sign of the inequality. Okay, and then the negatives cancel here, so 4x and positive 3 divided by negative 1 is minus 3. So here will be what our inequality looks like in slope-intercept form. Remember, we need 4 pieces of information. So we need the slope, we need the y-intercept, we need whether it's dashed or solid, and then whether we're going to shade above or below. Okay? So the slope right here looks like 4, or of course 4 over 1. Our y-intercept is this guy right here. He's negative 3, so that'll be our starting point. This is y is greater than, so not greater than or equal to. So that means the boundary line itself is not included in the solution set, which means my line is going to be dashed. And then y is greater than, so that means I'm going to shade above because it's bigger. Okay, so let's get to work and graph this thing. So our y-intercept is always our starting point, so let's go down to negative 3 on our y-axis. We're going to use our slope, which is 4, but remember, it's 4 over 1 or negative 4 over negative 1. Okay, so from here we can go up 4, 1, 2, 3, 4 over 1. We can do it again. So 1, 2, 3, 4 over 1. And we actually can't go down 4 and back 1 because we're out of room. So I'm going to grab my handy dandy straight edge here, and I'm going to draw a dashed line between these points. And I'm going to draw my dashed line beyond the boundaries of the graph, and then I'm going to put arrows on the end, signifying that my line goes on forever and ever. Okay, so here's my boundary line right here. It's dashed because it's not included in the solution set. So now I need to decide shading above or below. Well, we said it's greater than, so we're shading above. We made that decision earlier. So here's my y-axis, the vertical axis. So above means I'm shading up here. So my shaded region will look like this. Okay, so that's what this linear inequality will look like when I graph it. And again, if you're not comfortable with that, you can always choose test points. So 0, 0 is a great test point to use. So 0, 0. Also, this is my snowman point. Looks like a little snowman there. Okay, so when I plug it in here, we'll go to the original equation, or original inequality there if you want to. So 4x minus y is less than 3. And 0, 0. So my x value is 0 and my y value is 0. So 4 times 0 minus 0 is less than 3. So 0 is less than 3. Yeah, sure enough, this is a true statement. So the point 0, 0 lands in the true region, and that's why we shaded that. And of course, you can always grab another point in the non-shaded region and just verify that it's false, but it will be. So here's another example. It's the last one we'll do here. And it was not given to us in slope-intercept form, so we had to transition it into slope-intercept form. And then we grabbed those 4 pieces of information that we needed. The slope, the y-intercept, whether it's solid or dashed, remember, which means the boundary line is included or not included in the solution set. And then whether we shade above or below. So there's a couple of examples of graphing linear inequalities.